This is an AP video with a couple more examples of calorimetry calculations, which is 6.2. So these are in our textbook. They're review problems at the end. And I'm going to start with this one. So this is coffee cup calorimetry, so not a bomb calorimeter. And in the coffee cup, we always have water in the styrofoam cup. So we have 125 grams of water, and then we're also dissolving 10.5 grams of potassium bromide. Both of them are at the same initial temperature of 24.2. And after the dissolving process is done, the final temperature is 21.1. So we're going to calculate the enthalpy change of dissolution of the salt in joules per gram and then in kilojoules per mole. We're going to assume that the specific heat capacity of the solution is 4.18 joules per gram Celsius. So, first thing that I would do is think about the fact that the amount of heat that the solution is going to lose is going to equal the mass of the solution times specific heat times delta T of the solution. For these problems, I would recommend that you keep everything positive until the end and then only include a negative if it's an exothermic process. So in this question, I do need to know my mass of my solution, which is going to equal the mass of my water plus the mass of the potassium bromide, my solute. So when I add those together, I'm going to get 136 grams. So when I plug into the MCAT equation, I'm using 136 grams, 4.18. And then my delta T is 21.1 minus 24.2. That is negative 3.1. But I am going to just keep everything positive, and I'm also, because of that 3.1, going to round to 2 sig figs. So that is the amount of energy that is released from the solution. In the question, they're asking me for the enthalpy change of dissolving or dissolution. So enthalpy change can be measured in joules. So first one we're going to do is in joules per gram. So we're going to assume that no energy is lost to the surroundings or the calorimeter for this problem. And I'm going to have use my energy that I calculated for the solution divided by the grams of the solute, because this is the delta H of dissolution of that solute. So I would divide by 10.5 grams of potassium bromide. When I do that with 2 sig figs, I get 170 joules of energy per gram. And this is an endothermic process now. So, if you want to start thinking about sign, or if you just want to wait till the end. But basically, the Q of the solution is going to equal the Q of the dissolution or dissolving of the KBR. And we know that this value is negative because energy is, we did get a negative here when we calculated the Q of the solution. So the energy of the solution is going into the crystals of the potassium bromide to dissolve it. But again, I would keep everything positive till the end. So the other thing that they want is to know the enthalpy change of dissolving or dissolution in kilojoules per mole. So that would be 1.8 kilojoule, and then I would want to do my mole calculation. Sometimes I do it right in the problem, but this time I'll take it out. So 1 mole of potassium bromide has a molar mass of 119. So I get 0.0882 moles of potassium bromide. So both of these values are in terms of the dissolution or the dissolving of this particular salt. So now I can just, take 1.8 kilojoule per 0.0882 moles, and that would give me, with 2 sig figs, 20 kilojoules per mole. And like I said before, the negative Q of the solution that we got, if we had kept our temperature, would equal the positive Q of the dissolution of the potassium bromide. So our answers are going to be positive. And you can also think of it like the solution. Remember, its delta T was negative because energy was going into the KBR. So I hope that helps you with that type of calorimetry problem. And you can always practice more in the back of the book.